Hi, Algebra 1 students. It's Mr. Blome. We are having some technical difficulties, so I decided to finish up this last video. I know you're going to miss Mr. Mays, but get over it. It's me. You love me, or you can at least pretend to love me. Anyway, um, we're on the last section of write the rule for functions. Okay, so you should have all these checked off. We'll do one more booklet, one more practice assignment, and then you'll take the quiz on all three writing the rules. So go ahead and check that so you know that you've done it. Make sure you're keeping track and go ahead and go page 22. So we're writing the rule for a function. Okay, so this time we're given a graph today. So we've got this beautiful graph. And what we want to do is we want to find some points on this graph. The key to doing this is make sure that it hits directly on that corner. See how there's no point there? There's no point there, but here is a point. No point here, no point here. It's got to hit perfectly on that corner, or at least pretty close, so that you know you can get it. So this point is our x value -1 and our y value -4. Then we're at 0 for our x value, -1 for our y value. And for our last point, this is 1, 2, x, y, 1, 2. I can't find any more points on there, but that's all I need because I can start looking for those patterns that we've been looking for. So if we go from -4 to -1, well, the pattern is we want to add 3. If we look again on our change in y's, we're adding 3. If you look at our x's, we're just adding 1. That's the good one. Makes it easy. Okay. So when we go to write our function rule, we want to identify the pattern. We're adding 3 each time and write the function rule. So every function rule must have f of x equals, and then we kind of have to play around with this. We can see that this is a linear function, so we know it's got to be something with that x. And if we're adding 3 each time over 1, we do that change in y over change in x. We're going to learn more about that in our 5th unit, I believe. But what this is 3 over 1, which is really 3. So we say 3x, and if we try f of 0, we substitute in 0. 3 times 0 is 0. Okay, if we plug in 0, we expect to get out -1. Well, we're close. Well, let's do -1, -1, -1. So what that gives us is 0 minus 1, -1. Now I get what I want. Okay, let me test another point just to be sure. If I want to test f of 1, well, we know f of 1 equals 2. So let's substitute it in. So our rule that we came up with, I'm checking it right now, is 3 times 1 minus 1. Well, order of operations, 3 times 1 is 3, and 3 minus 1 is 2. Okay, we tested 2 points. We should be pretty confident that our function rule works. Let's go to the next one. So here's another one. We want to find some points. Here's a point. Here's a point. Here's a point. Here's a point. That should be plenty. I want to make an XY table. My x value, if I plug in 0, I get out 4. That's my point. If I plug in 1, I get out 2. You see, if you look at that graph. If I substitute in 2, I get out 0. And if I substitute 3, I get out -2. Now I want to identify my patterns. So if I look at this, this is -2. This is also -2. I'm subtracting 2 every time. There's my pattern. Okay, if I look at this one, I'm adding 1 each time. So when I look at my rule, f of x equals, well, now I have minus 2x. All right, and then I need to adjust. So again, let me test a point and see if my rule is pretty close. If I do f of 0, I get negative 2 times 0. Negative 2 times 0 is 0. Okay, but I need 4, so I'm off by 4. Well, let's add 4. 0 plus 4 is 4. Then I get what I want. See what's happening? I'm looking for my pattern and my rate of change because it's linear, and then I do this little bit of adjustment. That plus 4 adjusts it. Let me test another point. Let's test f of 1. F of 1 means I plug in 1. I substitute 1 for x. Negative 2 times 1 plus 4. Well, negative 2 times 1 is negative 2. Negative 2 plus 4 is 2. It worked. Woohoo! So this is my function rule. I wrote it. This is my answer. Okay, let's do one more. Now look, right away, you see that the shape is quadratic, right? That tells us that my function rule needs to be x squared. Something x squared. But if I look at it, this reminds me a lot of that shift. You see how I shifted from where it should be right here at the origin? I shifted it right 1. Well, that's a review of our transformations. If you remember, we have our f of x. If I shift it right 1, that's inside the parentheses. X and squared, and there's my 1. Now I got to remember, is it minus or plus? I could look back to my notes and remember that when I shift right, it's minus 1 inside the parentheses. Okay, let's find a point and test to see that works. So here's a point. 2, 1. So if I use my function rule and I test it, and I do f of 2, I better get 1 out as my f of x or y value. Okay, so if I plug in 2, 2 minus 1 squared. 2 minus 1 is 1. There I did my parentheses first. I did the stuff inside the parentheses by the order of operation. Now I do exponent. 1 squared is 1 times 1. 1 times 1 is just 1. So there I got what I wanted. I plugged in 2 and then I got out 1. So I tested it and it worked. Okay, we're not going to give you very many quadratic ones, but definitely a lot of these linear ones. Check those function rules. So this was my function rule answer.